Hello students, in this video we will be discussing Cbse class 9 physics chapter 8 motion, the 14th part. The previous parts have been discussed in the previous videos. Those have not gone through them, or if you have doubt in those concepts, please get back to those videos and try to understand. In this video we are going to start from this part with the derivation of equations of motion. We are doing all this having the velocity time graph as the reference. Okay, we are going to consider one type of motion of the of an object, and then we are going to derive the equations of motion. Okay, before we get into the actual derivation, we'll just go through the points which we've already discussed. Okay, we just recap through them. Speed will can be calculated from the slope of the dt graph. Okay, as I told you, in this equations of motion we are not going to consider the dt graph, but we are only going to consider the vt graph, that is the velocity time graph. So from velocity time graph, what can we calculate? We can calculate the acceleration and the distance. Okay, both of these we can calculate. Okay, acceleration and distance. And what does that mean? Slope is equal to 0. The graph is going to be a straight line parallel to the time axis. Another one is about the slope, which is nothing but the rise by run, which we get from the vertical change by horizontal change. Okay, now we'll get into the derivations. There are 3 derivations. Okay, so we'll go through each derivation one by one in each video. So the 3 equations of motion are velocity time relation, position time relation, and position velocity relation. You can very easily remember the equations of motion with these names. Okay, they will be also called this velocity time relation as the first equation of motion, this as the second, and this as the third equation of motion. Remember, it is velocity and time. So more importance will be there in the velocity and time while we do the derivation. We'll ignore the other parameters. For position and time, position talks about the distance or the displacement, so we give importance to s and t. Position velocity relation will be for s and v. That means we will have these parameters primarily in each of these equations. So with this knowledge you can very easily derive, because sometimes in your exam they may not ask you like derive the first equation of motion. They may tell you derive the velocity time relation or position time relation. So in that case you should not get confused. Okay, for that only I am giving you this method to remember it. As we go on with the derivations also, I will teach you, or I will tell you how to remember this. So first thing is going to be your velocity time relation. So before we get into the velocity time relation, this consideration is going to be the same for all the 3 equations of motion. Okay, so after this only we'll start with everything. What is our consideration? We are considering an object having an initial velocity u. See, you have an object here where this is the initial velocity u. Okay, so you have an initial velocity u. Okay, and is subjected to uniform acceleration. Uniform acceleration means how will be the slope? The slope will be a slanting line. Okay, it will be inclined with the time axis. Okay, so here from u only you are getting that slope. Okay, inclined with the time axis. Okay, so if this is the thing, it is inclined with this and reaches a final velocity v. Okay, it is reaching a final velocity v in a time period t. So we know this is going to be a vt graph. So v will be in the y-axis and time t will be in the x-axis. So this is happening in a time period t and covers a distance x. So it is going to cover some distance x s. Okay, so this is what is our graph all about. So from this graph you can make a note of all these things. Okay, see, you will have OC, AD and EB are going to be equal. Likewise that is going to be equal to t. Okay, see here, when you drew like this, when you draw this line, you can say that this line and this line are all equal, and that is nothing but your t. The next one is what? This one. So this OA is equal to CD. Can you see this? Yes. So that is equal to U. And here is where you have V. Okay. Finally, now OE. So this one you named it as E and this as V. OE is what? OE is V. Likewise, OE will be equal to CB or BC. Then you can calculate this mid value AE. AE is what? OE minus OA. Likewise, your BD. Your BD is what? CB minus CD, which will give you V minus U. Remember, with this we are going to start with the equation, the first equation of motion. For all the three equations of motion, these values are mandatory. These values and this graph is very important. Okay, so you have to be very careful with this. So this is what will carry you through all the three equations of motion. So now to derive the first equation of motion, as I told you, all these this diagram and the graph and these values are important. Okay, we know the first equation of motion is going to be velocity time relation. What is it? Velocity time relation. Okay, and we were talking about uniform acceleration and all. The basic thing which we learned first is nothing but the slope. What does the slope give? The slope will give you the acceleration. Slope will give you the acceleration. Okay, now let me write the slope. Slope is what? Rise by run. It is nothing but rise by run. So here what is the rise? Rise is nothing but, so you are going to take this triangle. Your slope is AB and this is your D. So rise is what? BD and your run is AD. Okay, this is BD and this is AD. So we've already got BD to be V minus U and AD to be T. So this is what? V minus U and this is T. Substituting it, what do you get here? V minus U by T. Okay, take this to the other end. You will have AT is equal to V minus U. Now take this U here. You will have AT plus U is equal to V, or I can say V is equal to U plus AT. So that's all. We are done with the first equation of motion. Remember, it is velocity time relation. See, you have velocity and time to be predominant. So you don't have much importance for S or any other thing. Okay. So thus we call it to be a velocity time relation. Are you able to understand, children? Yes. We'll do a quick recap again for velocity time relation or the first equation of motion. It is also called the first equation of motion. Okay. So what do we get here? You are going to calculate the slope, which will give you the acceleration. We also know that slope is nothing but rise divided by run. Here it is this triangle, that is this slope AB. You have D, so you have BD by AD, which is nothing but BD, you got it as V minus U, and this you got it as T. So V minus U by T. So slope is this, acceleration. Slope is this, V minus U by T. So what do you get? A is equal to V minus U by T. Taking this to the other end, AT is equal to V minus U. So take this there. You will have V is equal to U plus AT. Is it clear, children? Yes. Please try solving it once you listen to this video. So this is the very simplest and the first derivation in your NCERT textbook from the 8th chapter, motion. Okay, just go through this again. See, I have explained this nearly thrice in this video, so please go through it and try to understand. So A is equal to V minus U by T. We are getting it very easily. Okay, and then finally you get V is equal to U plus AT. So this is called the velocity time relation or the first equation of motion. So is it clear, children? Hope you understood this. If you have any doubts, please listen to the video once again. Okay. And also do the derivation side by side. These are very important, and this first equation of motion will be the base for doing the second and the third equation of motion. Okay. See you again in the next video with the next equation of motion. Thank you, children.